Welcome. In this session, we'll explore a simple example of linear programming. Linear programming is a linear objective subject to linear equality or inequality constraints. So let's recall or consider, let's consider a point on a line that satisfies. Now let's make this satisfies. Let's say that any point on that line is some vector w, and what we want is that some function has a level less than or equal to 0. So another way that we could phrase this is, suppose that we want a point on a line that is in the level set of a function. And if this function is convex, that's going to be a good thing. So let's take an example. So for example, suppose that we want to find an optimal point that is the argmin over all vectors in a 2 space, and then our line function from previous sessions was minus w1 plus 2w2 minus 4. So that was our line equation. So this is the line function. It's not an equation because it's not equal to anything. So this is, now what we can see is, well, hold on, there's a problem here because the argmin of this thing, well, this goes off to infinity, right? That to make this as small as possible, we make w1 as large as possible, w2 as negative as possible, and then, so this doesn't have a finite solution. Now, let's suppose that we add a linear inequality constraint. So what we'll do is we'll say that if we take the difference between these entries of w star, so we'll represent this as a 1 form times the vector, minus 4, and we'll say that has to be less than or equal to 0. So this is an example of a linear programming problem. Now let's visualize this problem. So the objective was we wanted to minimize, for example, a scalar argument of this function. Well, the feasible set for this would be the set of all points that satisfy our constraint. And so this is going to be a half plane that is, it has a normal vector of minus 1, 1 and an offset of 4, and any point that is on the positive side of that hyperplane is going to be in the feasible set. Our line will have a different equation, and so now this makes sense. What we want to do is find the value of t such that it's just barely in this hyperplane, right? And so it'll be that point there will be the constrained minimization. So this is a really simple example of linear programming. Linear programming is sufficiently complicated that there are entire courses devoted to it. We won't look at linear programming very much, though.